Good day, I am Edward Vincent Mascara. So our topic that I'm going to discuss is all about Raspberry Pi. So what is Raspberry Pi? So Raspberry Pi is a small, affordable and versatile single board computer developed by Raspberry Pi Foundation. It is essentially designed to promote computer science education, but due to its flexibility and low cost, it has gained widespread use in various fields such as robotics, IoT, and cybersecurity. And the purpose of Raspberry Pi is Raspberry Pi was created with the goal of making computing and programming accessible to everyone, especially students and hobbyists. Its primary purpose include educational use, like teaching programming, project development, used for develop or building IoT device, prototyping and research. Engineers and researchers use it to test and develop hardware and software solutions, and media centers and retro gaming. Many use it to set up media centers or CODI. Cybersecurity and networking, commonly used for penetration testing, VPN servers, and firewalls. So we have different kinds of Raspberry Pi. So we're going to start in Raspberry Pi 4 Model B. So this is best for desktop computing, AI or machine learning, media centers, networking, and IoT project. So why it is best for? It is because of fast quad, and Raspberry Pi 4 Model B has a Core Cortex A72 CPU and up to 8GB RAM, make it ideal for multitasking. USB 3.0 ports allow fast external storage and peripheral. Dual micro HDMI ports, supports 4K displays, making it greater for media centers. And next is Gigabit Ethernet and Wi-Fi 5, and also it is suitable for AI and machine learning workloads. And next is Raspberry Pi 3 Model B+. So this is best for IoT, robotics, home automation, and lightweight servers. So why it is best for? It is because it has a quad, but this has a Cortex A53 CPU, balanced power and energy efficiency, and this is Wi-Fi 4 and Bluetooth 4.2, make it greater for smart home projects. And Gigabit Ethernet limited to 300 Mbps provides reliable connectivity for servers and lower power consumption than RPI4, making it better for IoT and robotics application. And next is Raspberry Pi 0 2W. So this is best for low power IoT project, embedded systems, and portable applications. So why it is best for? Because it has a quad core CPU like RPI3 but lower power, and also it has a Wi-Fi 4 and Bluetooth 4.2, and small form factor, so it is smaller and can be powered by small battery, making it greater for remote sensor projects. And next is Raspberry Pi 0W. So the best for small scale IoT project with lower performance needs. So it has a single Core ARM11 CPU limits performance but works well for basic automation tasks. And the minimal cost is $10 to $15, making it perfect for large-scale deployments, and best for simple projects like temperature sensors, weather station, and basic automation. And last is we have Raspberry Pi 400, best for education, basic desktop computing, and coding practice. Why? Because first is keyboard. Integrated design make it all-in-one beginner-friendly computer, and a faster quad because it has a Core Cortex A72 CPU than RPI4, optimized for casual use. Great for coding tutorials, web browsing, and light office work. Ideal for students and beginners learning Python, Linux, or Scratch programming. So the essential part of Raspberry Pi is first is CPU, RAM, so GPIO or general purpose input, output, and storage options, USB ports, networking such as Wi-Fi, Ethernet, Bluetooth, and video and audio ports, and power input. So simple project using Raspberry Pi. So we have two, I think. Yes, we have two Raspberry project. So we have first is solar Raspberry Pi power pack. So the brief explanation of this project is a system that allows a Raspberry Pi to run a solar energy, making it ideal for off-grid application, remote monitoring, and IoT project. It typically consists of the following components: solar panel, charge controller, rechargeable battery, and voltage regulator. So how it works. So daytime, the solar panel generates electricity, powers the Raspberry Pi, and charges the battery. So nighttime or cloudy days, the battery supply stored energy to keep the Raspberry Pi running. So the use cases of this is remote weather stations, IoT sensor networks, wildlife monitoring, and off-grid projects. Next is we have a Raspberry Pi medical device input shields. So Raspberry Pi medical device input shield is an expansion board that allows a Raspberry Pi to interface with medical sensors for real-time health monitoring and diagnostics. It acts as an interface for collecting and processing biomedical signals. So this is the key features and components. So sensor interfaces, analog to digital converter, amplifiers and filters, wireless connectivity, and power management. So the use cases of this is wearable health monitoring, telemedicine, biomedical research, and emergency response. So as you can see, this all of the device that you can see here is an Raspberry Pi. And yeah, that's all, and thank you, sir.